I'll just start. First of all, thank you very much everyone for coming tonight. It's a very nice turnout. I'm so happy to see you that you've made the effort to be with us tonight. Welcome to the Data Engineers London Meetup March 2024. I am one of the co-organizers. My name is Anna, and I work as a data engineer at the John Lewis Partnership. So go ahead. Thank you for our sponsors, weshape, for making this event happen tonight. And I'd also like to announce that we actually have gone into partnership with weshape, so that will, basically what that means is that we're still a separate entity, but it just means that we will be able to bring you these kinds of events a bit more regularly. So I think the last one was here like in November, so that should increase. I'd also like to introduce my fellow co-organizers, Harry, Jamie, and Duke. Are they here? Oh, Jamie's there, Duke's here, and Harry was welcoming you upstairs. So if you have any questions about the event or you'd like to get involved somehow in the future, just feel free to come up to any of us and ask us anything you'd basically like. Here are the future events. I haven't created meetup groups yet, so just keep an eye out on the upcoming one. So the next one should be, all going well, on the 15th of May. And the topic for that will be ETL or ELT. Maybe if someone would like to give a go as to talking as to what the difference is and why would we choose one over the other. And Wednesday, 17th of July, we're going to be talking about distributed systems / quantum computing. Because I think it would be quite interesting to have a little bit of a discussion as to how quantum computing can impact the field about data engineering in the future. And if you'd like to just RSVP for now on the meetup groups, so just click attending in the future. And if you would like to participate, you can submit a talk. It doesn't necessarily has to be on the topics that were listed. If you have anything you want to stand in front of a crowd and talk about, feel free to submit a talk, and that could actually, inspire our talks in the future. We have social media. We have a LinkedIn, so that is kind of the best way to keep track of all the updates for meetups, so feel free to follow us there. And we also have a YouTube channel where you will be able to watch me talk about this in the days to come. And also you can see our meetup from November 2023 is up there as well. After this, we will be going to a pub, and we will say it's right down the road. It literally is right down the road, 3 minutes away. So if any of you feel like hanging around and having more talk about data because you haven't had enough, please feel free to come along to that. And I hope you enjoy Ibuka's and John's talk about data modeling. I feel like, me personally as a data engineer, this topic gets talked about kind of like offhand, but no one actually ever, when people say, yeah, we're going to be doing data modeling now, what does that include really? Does that just include me putting together a graph? Or what does that include? So hopefully Ibuka and John will be able to inform you of that tonight. And that is all. So Jamie would like to just do a few words about weshape and what they do and how you could, just an introduction about them. So while we do a setup for Ibuka, please, if you'd like to give him a listen. Yeah.
But yeah, no, thank you for coming tonight. There's so many of you, it's quite scary up here actually. I work for weshape. We're a technology consultancy. We're sponsoring this event and also one of the co-organisers. But what weshape are a technology consultancy that specialise in the advisory and implementations of data, DevOps, software, and cloud-native solutions. One of the things I wanted to say, we do actually have a number of data engineering projects in flight at the moment. So if anyone's interested in new opportunities, particularly on the contract front, come and have a talk with me later on today. But also, we're also partnered up with AWS and GCP. So if anyone's interested in getting any certifications in that, give me a shout at the end, or any of the team. You'll see us. We're probably all wearing the same T-shirt, to be honest. So it won't be hard to spot. But yeah, give us a chat about that. We'll talk to you how we can get you through those qualifications as well. But I hope you enjoy the talks firstly and foremost. And yeah, thank you for your time. Cheers.
So if you'd like to welcome now Ibuka, who has come all the way from Cambridge, well, Manchester via Cambridge, to be here tonight.
Chukwuebuka Akwiwu-Uzoma. I work with semiconductors. I have been working as a data engineer for the past 5 to 6 years now, and I wouldn't want to do anything else. So, for today, we'll be discussing data modeling. Why do we even bother? What's the point, right? Just to gauge expectations, it will be more of an introductory class, introductory basically, on why we are going to be doing this, why do we need to do this in our ETL processes. So the short answer for why we even bother is to have a structure that we can build upon. Say you have data coming from different locations, you have API data coming from your product data, you have data coming from the actual databases, data coming from Excel sheets, disparate sources. So we want to create a structure that is kind of that we can use across all platforms. We can use for analytics, for science, and whatever data needs we want, basically. So yeah, a typical work environment, you start a role and as a data engineer, junior data engineer first role, and you come into contact with API responses, right? And let's say you started as a data analyst, not data engineer, and your boss asks you to analyze data coming from the API. So what tool are you going to use to analyze that? How are you going to go about? So this is a Formula 1 API data. It's a free API data. Here we have drivers data, basically names for drivers, right? And their personal information. And here we have the race results, who came first, second, third, and the rest. And you want to analyze a driver's performance along the years. How are you going to make this to make sense of it to provide something on Power BI for visualization or Tableau in that case? This can't work, it's not possible. There are caveats how you can go about it, but it doesn't make sense to have an ad hoc process every single time. So the whole aim of data modeling is to create a structure that we can build upon. Let's say we have a driver's table, right? We have a race table, we have, sponsors table, right? Red Bull or the rest. So we can actually merge this and create some insight from that. So, like I just mentioned, data modeling is basically trying to understand, right, your data first. You need to understand what we have here. This is the driver's data. Understand the format it's coming from, is JSON. What are the contents, right? And some other details that we may list going forward. And then you need only to define the relationship between these. So for these two tables, two responses, API responses, how are we going to link these two together? What are the relations between them? So here we have the driver's name or driver's ID, whatever, and here we have the same driver's ID. So if we have two separate databases, we can actually link them by this. Okay? So the modeling is trying to understand these data, right? The content, the relationship between these two, and trying to draw more of a diagram to show this relationship so that you can actually implement it. And finally, creating this in a database, or a warehouse, or a lake house, whatever you want to utilize. So the process is, create the structure, understand your data, create the structure, transform it, right? Create a relationship between those, and then analyze the data. To actually do modeling the right way, there are three basic concepts. More of processing steps. We can't just change that to steps. There are three basic steps. The conceptual modeling, this is where you do the actual talking with the business and talking with the stakeholders. Say you have someone from products coming to you and say, we would like to analyze product data before we even, to know how we're performing. Before we go live, we need to be able to analyze data, right? So we need a structure that will allow us to analyze data when we go live. So you have to ask the product person, we would like to basically interrogate the product to understand, okay, what are the different entities within the product? Do we have customers? Do we have orders? Do we have all those kind of things? So if it's a product that ships orders to customers, so basically you have a customer entity, right? You have the customer makes orders, and obviously the order gets delivered. You have the order being delivered by a branch of the company, right? So these are entities that are important to be able to analyze, to get your model right. So the first step is to conceptualize it. Break down your product or your data into different entities, right, to understand them. And the second step would be, obviously, you wouldn't want to stop there. We have identified what we want to model. However, we need to create it in a way that it can translate to technical stuffs, right? We have databases. How do we translate these to technical stuffs? So, for using Postgres database, how can we translate that to look somewhat like Postgres, right? And the last part is the actual modeling, implemented it. So these are more or less guides, steps that are necessary, right, before you can actually achieve a data model that works. Let's say for the instance I mentioned, we have this, we've identified we have products, customer makes orders, and the orders are about products, and the orders are being delivered or dispatched by a branch of the company, right? And that happens on a specific date, that kind of stuff. So we're able to kind of create a visual concept of what we want to achieve, right? Once we have this, we can then go a step further and say, okay, can we identify the attributes, that is basically the features of each of these entities, right? So for a product, obviously every product that's being sent out will have an ID, right? It will have a name, category means children, babies, and the rest. Others will have a transaction date, ID, and the rest. So customer will have a customer name, address, and branch also will have some ID. So we're able to, yeah.
So, like, when would you decide to have date as a attribute versus its own table? Like, what determines that? Because it can also be a column, right?
Sorry?
The date.
Okay.
Why did you make that as its own table?
So there are instances when you might want to have a date dimension. Say, you know how maybe I should answer this at the end of the question. Yeah, at the later end, I can talk about that, okay? But for now, I'm going to talk about that. So let's say we have a date dimension there, okay? And then we'll identify these particular attributes of this business that we want to model, right? And the relationship between all these models. Next thing is actually implementation. For implementation, we have made a choice saying, okay, we want to go with PostgreSDB or Redshift wells or whatnot. So each of these specific data stores have their particular way of implementation, right? So the next level would be to create the physical model. If we decide to go with Postgres, we have to define the data types that are usable in PostgreSDB. If we decide to go with Redshift, we have to make sure that the data types tally with Redshift data types. So the physical model basically states the actual implementation with the particular data store we want to store that data, right? So this is what it will look like. We also have to decide the degree of normalization, right? But I'm going to talk about this towards the end of the talk. There is a trade-off between reduction in normalization. I was on the talk with one of the attendees. There is a trade-off between degree of normalization and performance analytics. So I'm going to discuss this at the end of the talk. So this is just two basic instances of physical model. We can have a physical model in star format, star schema, or we can have it in a snowflake schema. Difference between these two basically is, for a star schema, everything revolves around the facts table, right? Every other dimension points to the fact table. While for a snowflake schema, you can have other dimensions that are pointing directly to other dimensions. So it gives you a snowflake schema, basically. Yeah. Data modeling techniques. So there are different ways you can actually represent data. The one I just showed is basically the way you represent data in a normal relational database or an OLAP database, right? Which is prevalent in the data world. However, that's not all the data models we have, or techniques rather, okay? We do have ER. Basically, it is a conceptual model, basically. It's close to what we have here. It's close to what we have here, but not really. There are particular technical terms to it. It just shows the entities and how they relate to each other, right? The ER diagram. Then we have a hierarchical model. A hierarchical model would be something like this, where in the workplace you have the CEO and the trees behind it, basically a tree-like structure, right? We have the graph model. This is typically used. I worked in a crypto company, fintech company basically, where we wanted a way to represent currency arbitrage and currency mapping. In that case, you may not want to store your data in the normal format you want. So this is an easier way to show relationships, right, between data points, right? To change from yen to euro, this is the conversion rate, this to this. So for those working in finance, if they want to arbitrage, okay, how can I make money from going around this tree? Is it easier to go through this, and this? Will I make more money doing that, or going through this, and this? So it helps you analyze data better, right? So it must not be the relational way, right? So graph model is one of those. We have the relational, which is basically what I showed, and the star model and snowflakes. There is an argument that these, which I think is true, star model and snowflakes are more of a derivative of relational, right? They are basically, star models are centered around facts tables, right? And snowflakes, something centered around fact tables, while these just shows the relation between one or two entities. Any questions at any point? Okay. So, yeah. So we have hierarchical, graph model, relational, star, and snowflakes. Relational, star, and snowflakes are relatively the same thing, right? In that sense, they are derived from relational, basically, that's what I mean. So, yeah, the practical scenario I was talking about. We can go the route of the API or this data I have here. So we have the typical business with products, offices, sales, and customers and their relationships. And we have this data here. Can someone tell what are the issues with this particular data set we have here? They are in tabular format, granted. It's relational. I think you can analyze it, right? What are the prevalent issues we have here? Yeah?
In column 2, there are one in a row in column 2, and I think a couple of other columns, you have multiple values rather than have them in separate.
Exactly. Even though this is a relational database, we are storing this in a table, which is easier to analyze. This violates the first normal form. We are storing more than one value in a column. So knowing how to store data in a database, right, in a table, does not mean you understand how to model it. They are two different things. So this is one issue. Another issue?
In the customer location, the UK is duplicated.
Customer location.
You've got Manchester and the UK.
Yeah, that's one thing. Here as well, we are storing two informations. This is a city and this is a country. We can split this out. Yeah?
Should you not be separating the name for customer name, like the first name and surname?
Exactly. So here we have just first name, while here we have both first name and last name. So that doesn't conform. Yeah? Yes, I intentionally did that one actually. Yeah.
There probably should be a separate table for customer. The customer could change their name, but it's the same person, or change location.
Exactly. Thank you. So knowing how to store data in a table does not equate doing the right modeling. So that's what I wanted to point out. For any business, it's very critical to, yeah.
Another one is we have a primary key which is
duplicated.
And we do not have business key. So with, if you're going by primary key, there is no asset information in this.
Exactly. So, yeah.
Yeah, I think primary key is fine. It's with a transaction ID is slightly not consistent.
Yeah, it's repeated.
Hmm?
You said it's repeated, right?
No, you have same transaction in different stores.
Same transaction, different stores.
That's not business consistent.
Yes. This is intentional, basically. I wanted to point this out.
Okay.
Yeah. So this, I wanted to point out the issues you can have by storing data in the database without doing it right. Okay? Yeah.
It's kind of mentioned of normalize this table. So one mentioned for the location, but also like the store ID is still so much. Instead of having both of that, you just have the store ID and then normalize it in a different table where the store ID will be a foreign key.
Exactly. Yeah. So we can break down the store, right? Push the store details into another table and just retain the store ID here. So yeah. We've already mentioned the issues actually, so I'll just skip that. Okay, so next to the aim of any data modeling is to go from this basically to a more structured format. Why we do this is not just for the analytics, right? We need to have a way to build upon the existing structure, right? If we are creating a table just for the aim of analytics, let's say for the product on its case, right? He wants to see the trend of a particular data, customers, right? And you build a model just based on that requirement, creating a table that answers that question. What happens when your manager comes and says, I want to have a deeper understanding of that data? You have to go and create a different model for that. So the aim of modeling is to create a base where you can build upon, right? Have a stable base that you can connect together. If my manager says he wants to see data about customers, I can just add these two together and get what I want. If the product person wants to understand the brand performance, I can work with these two. Oh, yeah, these three, right? I want to know my manager's performance, store manager performance, I can work with these three and arrive at the same result. Well, different result, but easy. So the point of doing this, creating this, is actually to have a base that you can work with, right? Yeah, same thing I just mentioned. To materialize any view, any table, it should serve one of two purposes. It should be source for analytics or a base for upstream. If it doesn't serve those, it's just wasting your storage and you're also wasting your processing time. Okay? So if you don't need to use the table for each of these, you can just store it in each raw format. So in your businesses, if you're not answering these questions, right, you're not doing it right. So, so what are the benefits of data modeling, which we've seen from this little intro? Obviously, from the table we have an organized view, right? An organized storage, basically, that we can build upon. Secondly, it improves DB performance. Data quality, I think it's a bit obvious as well. For the DB performance, actually, for the database performance, assume you have to, let me just put it this way. For this, now, every time you're trying to insert new data to this particular database, you will be replicating Chukwuebuka's name in case if Chukwuebuka is a customer that did the transaction, you'll be replicating his name every single time, which is a problem. If consider replacing Chukwuebuka with 1 in this case, we have how many ASCII characters here? About 10 or whatnot in Chukwuebuka, and we have just 1 character in my ID, right? In my ID. Obviously, this saves you a lot of space in that regard. We have 1 character as against 10 characters here. That's 1. When you want to perform analytics as well, if you do not need to use all the tables, if you just want to analyze data concerning these 2, you can actually point to these 2 tables. It is way faster to connect to these 2 tables than the whole raw data you have, unstructured raw data you have, semi-structured in that way. So, reading performance is improved, right? Writing as well is improved, and storage as well. It also offers room for collaboration. This is where analytics engineers actually gain more from modeling. If you have a base model from the structure we just had, right, it's easier to build upon that, to collaborate on that, create different views from a structure than building from the raw data. Ease of analysis, that's obvious as well, and data deduplication. Modeling deduplication basically means not repeating data within the table, removing duplicates in the table.
I have 2 questions.
Yeah.
One of them is, I heard in GCP training, they were saying that having an array, like in products, no less, everything is efficient for storage.
Sorry?
It's efficient.
What is efficient?
Rather than having too many rows for the different products, having all together in just one. And then if you want that to expose that for analytics, then you can normalize it.
Normalize. Yeah, so I will come to that. So this is a trade-off I was talking about. There is a balance you have to strike when it comes to analytics and storage. It is easier to store data in normalized format, but easier to analyze it in denormalized format. Okay? So normalized format is basically having what we have here, broken down into separate bits, big, right? And if you want to analyze that, there's an extra processing task of having to do the joins. You have to join this to this, just to this. That obviously is a bit processing intensive, right? Before you can actually get what you want. For analytics, what the goal is usually is to have this table as long as you want, as possible. It makes it easier because you don't have to join it again. You definitely just point in the main table and analyze it. But what happens if this is the only table you have? You don't have this base, and you want to create another view, right? You want to do another join. What happens then? You are basically utilizing a very huge table, right? And then joining it to another small table. That will be representative as well. The usual goal is to have something structured this way. For analytics, you can build upon this create a view of a table, a materialized as table, that has a join that would always point to visualization. Right? Have a base to work with. If you want to then analyze the data, get the core entity that are important for analytics, join them and materialize them, and then work with those. You don't have to, so it pre-aggregates it, it pre-joins your data before it needs for analytics. But if you don't have this, and you want to change your format, you don't want to analyze the data, it's kind of hectic trying to go again from the source to get to that point. Do you understand what I'm saying? So you can have this, then join the columns you want, join the particular tables you want, create a structure for your state analytics, and work with that. It will perform better because you already joined it before you do the analysis. Okay? So that trade-off is really important. You need to understand when to create your denormalized table, right? If you do it from the raw data directly, you won't have something to work with. If you change your mind that that's not what you want to work with, it's best thing to create this and then build upon it. Okay? So yeah, that's pretty much the introduction I have today. And I'm going to go ahead and answer the question he asked here. Why do we have to take the date as a dimension? So so I work with a transaction company, fintech company, where we have to do a lot of things with data, get on quarter, get on year, get on financial year, right? Isn't it easier to have a dimension where you can actually pull this easily than having to pre-calculate every single time? So if you want to, because if you want to get this quarter, let's say you have this for this. Sorry. Let's say you have this, for instance, right? This is just a table. There's no date dimension, and you would want to get data for everything that happened in Q1, right? You can do a join easily to these two tables, right, and get your quarter data. This is not really necessary if your analysis does not require this breakdown into these different formats. So a product company might not be interested in all this. A transaction company that processes billions of records in a quarter might want to do aggregation on this. Depends on what you want to view. It's easier to do this join and calculate what you want to calculate than doing the casting or this conversion on your data. This is more resource intensive. So this is pre-calculated table. This is just, you have to do it by yourself every single time. You understand that? Any other question?
Okay.
Yeah.
So when I was looking at the table, so you know when I was looking at the table, I know with primary keys, it's best practice to use a natural key for one of the columns which actually exists rather than something artificial. And I looked at the customer table and I saw that the customer ID was an artificial key. Obviously, you'd usually want like an actual key because it is better for data integrity. But my question was, I just couldn't think of a better way of doing it. Like I couldn't find a column which would fit naturally in the facts table, which could then serve as a primary key. So basically, in which situations would you deem it necessary to use an artificial key rather than a column from the table?
Anybody want to help us with that? Yeah?
Well, I think that depends on the company system, because the company may want a unique field across the company's whole platform rather than a single one. So the natural key customization may make no sense. However, but for a custom key cross company, use that as a primary key to the whole system, link back. Then one can create artificial key in the individual tables. So it's more like this rather. A lot of systems you may have machinery. Your natural key makes no absolute sense. You rather create a unique key instead.
Thank you.
just wanted to give a second reason. For anonymization reasons, you do not, let's say it's name, addresses, you have to analyze the data. You do not want to have any link to the data. So you might as well make an artificial key. You will satisfy the UK GDPR regulations.
Thank you. Thanks for saving me. All right. Okay, yeah.
So, this question, so just to give you context, so I'm more of a front-end engineer who sometimes do full stack development. And like, so let's say for testing, if I'm doing some, unit testing or integration testing, how do you, if you don't want to, of course, mess with your production data, do you, what is the strategy? Do you copy that into another database and use that for testing purpose, or how do you do testing with data?
I know. Thank you. I know that most established companies do have their platform, UAT, and the rest. But if you don't have that, obviously, for you to be asking, it means you don't have that. The other way would be copying, because you wouldn't want to actually point to production for any testing at all. And there are easier ways to copy the data, right? Normally, the way you might be thinking of might be writing a query to select all and then inserting back. You can ask for a dump, someone can actually get a dump for that DB for you and then duplicate on your instance. You can use Docker to create a little instance, right, of the same database, Postgres or whatnot, and then you can create a dump for you, and then you import the dump into your local and work with that. But usually most companies do have a testing database that you can work with, which is replicated asynchronously. So it depends on what you have, and if you don't have that, you can then.
So will it have all the data or just some data? Like, will it be as big as the production database, or does it?
The dump you can actually, so if you are asking for a dump of the DB, it's going to be everything. If that's not what you want, then you can do the manual process of writing an export of limited sets, basically. But yeah, okay.
I think we'll have time for one more question. And if not, then we'll take a 10-minute break. 10-minute break it is. Feel free to get some more drinks. If there's more pizza, you're more than welcome. And then we'll be back here for Jean's talk afterwards.
Hi everyone. So yeah, it's really a pleasure to be with you this evening. So just to introduce myself a little bit, I'm a software engineer since 8 years now, and I've been a data engineer for 7. So I've really transitioned very quickly into data engineering, which is a specialization of software engineering. And I've actually worked with a lot of different companies of all sizes and really all sorts, and solving a lot of different problems, especially in the data engineering and pipeline stuff. Yeah, I've really seen a lot of different challenges, and what I'm going to present to you this evening is, I think, a great solution to most of them, or many that I've seen anyway. Yeah. So yeah, let's start with a nice code. So data tables should be visualized as scalable models, built as targets, idempotently, and tested. What is hard to pronounce. Yeah, this is a summary of, I think, what we want in general, within the space. So models, so we want the tables, if you must visualize them as such, to be created in a declarative way, as opposed to having to go through all of the fuss of figuring out the steps to get there. Scalable, we want everything to scale, obviously. We want to build as targets to have the very tried and tested multi-tiered environment, to be able to reproduce things in different environments. We want the runs to be idempotent, to make sure that we can reproduce the same thing 2 times. And test it, tests are really important. So yeah, and tonight we're going to talk about Data Vault 2.0 on DBT. So just to get like a sense, who here knows about DBT or has used it? Oh, that's great. Cool. Yeah, we have quite a few aficionados. And who knows about Data Vault and the principles? Good guys, good for you. Good stuff. Yeah, so let's get into it. So let's first start with DBT. So let's see DBT a little bit more in detail. So DBT is a transformation tool that uses SQL to define and manage data models within an ELT framework. So there'll be more talk about that next time. But just to explain, ELT is extract, load, and transform, as opposed to the extract, transform, and load that we all know. It facilitates version control and testing. So that's the definition that you'll find in most places. My definition is that DBT is declarative, which means that you just declare what you want and then it takes care of the steps to get there. You define data models, so things are very organized into tables, which is the natural way of thinking for us. And the transformation using SQL, which is actually very powerful, and I've actually seen that myself. It's really powerful to have something that doesn't need Python or any really good programming language, because then you can get a broader audience of data analysts to help you, which is easier to find, and etc. So I think that this is really powerful, and that's one of the key strengths of DBT. And it actually integrates testing as well with a really good Great Expectations library. So yeah. So if there's like a DevOps audience, I like to present it as a Terraform of ELT. Yeah, for the DevOps people here. Let's start with the benefits. So DBT has adapters, which can be seen as connectors for a lot of different databases. So yeah, we've got the first one is the effortless scalability in the cloud of your choice. That's how I like to call it. The second one is for those who prefer an all-in-one Spark workspace. The third one is a great way to run serverless Spark jobs or Python jobs in AWS. Dremio could be seen as the Rebel data warehouse. Redshift is the deprecated AWS solution. Trino is the engine that breaks down silos with its multi-database querying capabilities. Athena is a great way to query quickly your data from S3, and then also to get a proper data warehouse in production. BigQuery is an amazing thing that the GCP community has brought to us. Azure is the Synapse Analytics is the great data warehouse inside of Azure, which is ever evolving. DuckDB is a great database when it comes to having a front end or kind of on the fly analytics. And we have the good old Postgres, which is here, alongside with MySQL and Oracle, which I didn't list there. When you did, the slide very sexy, not having that. So it's really compatible with a broad range of databases, and that's something that is actually beautiful, because you can actually develop your code, let's say for Snowflake or for Athena, and then later on, if you decide to migrate your provider, you can actually just take your code to another warehouse and then be able to reproduce everything. And most people don't write a lot of adapter-specific code, so then you will be able, for real, to take something like 98, 99% of your code and just take it there, and then it would work. So that's something that we really like about DBT. So that's an example of a DBT model. So basically here, this will build a table called order summary, because the file is called order summary, you can see on the top. And then as you can see, it's as simple as a SQL query. That's why we love DBT. And so here, it actually contains a source and a reference to another table, and a source, which is a table that already exists in DBT. And then when you run DBT, it will create a table without asking you anything else in your warehouse. So that's really the power of DBT here. And yeah, as we know, data tests are important. Where really sure that most of you have found that perhaps the hard way. So yeah, it's really easy in DBT to actually create tests. So there's a great library called Great Expectations, which is really standard for testing, for example, in PySpark. And DBT really took all of its inspiration from that, as yeah, it's actually pretty much the same test there. So you have a few baked-in tests that you can use, and you also have a great community behind, which has created a lot of different tests for geodata, for all sorts of things that you might want. And then you can just use them, and if you want, you can just actually define those. So yeah, we can. Yeah. So yeah, that's how you would write tests in DBT. So you would just declare your tables, the test, and then DBT will execute them all, and you will get just a very nice test report with all of the tests that are passing. You could also inspect the rows that are passing and see the counts and all. It's actually very simple yet very advanced. Yeah, DBT also has data lineage baked in, so that's actually great as well because it's always a pain to orchestrate things within your ELT, ETL, and then to have to see, shoot, I forgot that this one was coming before this one, or sometimes circular dependencies, it will actually detect them. So yeah, so it's actually baked in with no efforts whatsoever from your side. So if we analyze quickly this build order, so this model will be built first because it has no dependencies. Then these two will be built second after the first one has been built because DBT will pick up that it depends on them. And then DBT will also pick up that they can be built in parallel. So what it will do is that it will schedule the two queries in parallel inside of your warehouse, and then the third one will come afterwards. Yeah. So yeah, that's why I like to compare Terraform with DBT because it's got a CLI, much like Terraform. So you just have to install it in your computer, then via a simple pip install, and then you can use a CLI within your project. So here I've actually used the DBT run CLI, which is the most common operation to run all of your pipeline and then build everything, and then afterwards, it resolves the dependencies, compile your code, etc., and then execute all of the queries in order in your data warehouse. And then you can see all of the models and tables that have been built. So you have the full details with the time to build them, etc. You have also a summary of your run. Just if you want to check quickly, which we all do when we're in a large project. Yeah. So yeah, just to touch a bit on the reference DBT architecture. So DBT is very version controllable, and it's actually recommended that you plug in Git with your DBT project, much like Terraform. Then you actually depend on an orchestrator if you use the open source DBT. So you will need something potentially to orchestrate DBT on a daily basis or hourly basis, just to rerun your table, just to refresh them. Then yeah, you have the DBT component, which is actually on a Docker image. So people deploy that generally on ECS Fargate, Azure Container Instances, or perhaps Kubernetes. Yeah, what you shouldn't do is to deploy that on Lambda. I've actually seen that, so yeah. Right, so it's very pluggable. Then yeah, if you're starting to have a very advanced project and semantics and all, you can actually plug in a data orchestration tool, such as Monte Carlo, which is awesome, RE-Data, which is wonderfully open source, or the Granular Orchestra, which I really love. And then yeah, DBT will build everything into your warehouse, and yeah, that's your reference open source DBT architecture. So DBT comes in two flavors actually. There's the open source DBT, and there's also DBT Cloud, which is the software as a service offering from the DBT Labs. So open source DBT is free, but you've got to deploy it yourself. And that can be a bit of a pain sometimes, if you want to like do it well, you'll have to be fairly good at DevOps, build your own CI/CD pipeline, and etc. So I tell you that it's great for like hacking if you're just getting started with DBT and you want to explore the tool, or for very large scale project and organization. And then you have DBT Cloud. So DBT Cloud actually provides a great analyst experience. So for example, if you have people in your organization that you'd like to contribute to your pipelines and they're not so great at Git or like actually using like an IDE, which is something that I've seen a lot, and these people are like actually very useful. So you should try to like leverage them. Then like DBT Cloud is a great solution for that because it actually offers a great analyst experience. So it's got a baked-in web ID, which I'll show you, where you can actually, you have everything in like one window, and it's not very difficult to use. It's got a Git integration to manage Git operations. Then you also have the file view. You've got, and that's my favorite part here, the CLI to directly execute DBT inside of your web browser without installing anything. Then you've also got the data lineage, which can become very handy as you get to a more complicated project, and you have many different models and etc. And you have the code view, and then you also have a built-in orchestration with medium functionalities, but that works very well. Nice features like model timing. It runs DBT for you, so you don't have to install anything in your cloud provider, and many other features that I'm not on the payroll, so. Then that would be like a slightly different architecture, as you would do more things inside of DBT Cloud per se. So generally, people would first log into DBT Cloud through the UI, then they would create a feature branch in Git, then you would implement all of the changes, then you would run DBT run for them, then you would do your test, and it's pretty much the same, but a lot of steps run actually inside of DBT Cloud. Right. So these are all of the benefits of using DBT in general. So you've got a declarative approach to really declare what you want, and then DBT takes care of that for you. It's a standard tool. It's compatible with many different warehouses. It's got a great and growing community. It's actually here to stay. We can really see that. The table dependencies are resolved automatically. It's also got powerful macros and Jinja templating. So if you want to do kind of your own stuff or template a few things, you can actually do that with Jinja, which we all love and hate. And it's also got some great testing features as well, which is stemming from great expectations. It's got a lot of community packages that are actually very helpful, and can lead your project into a very advanced project in a few steps, so that's great. It's also very scheduler friendly and Git friendly. You can also develop locally, which we all love, because it can be a bit hard sometimes to do all of the queries locally when you're doing your raw Python thing, or for example with PySpark. It's very analyst friendly, as you can just write everything in SQL, and then your analyst can help you. So that's why we love DBT. So now let's talk about Data Vault 2.0, which is a great way to actually model data, which I think is overrated, especially for large-scale projects. So, it's, I'd say, not so new, but still fairly new from a community standpoint in the data architecture. It's really made for scalability and flexibility, because basically you can just change your schema a bit more quickly, or if you need to add or remove things, it's a bit easier when you have Data Vault. It feels more future ready as well, as in you don't need to remodel everything every 6 months, and it's a bit more resilient for large data scale as well. So that's a star schema modeling. If you've been following the amazing presentation before, So here we've got our fact order table, and perhaps the fact order item table, and the rest of the tables would be dimensions. So yeah, we know all of that fairly well. I don't know if you can see, by the way, because I realize that the lines are very slim, but these are join keys. Hope that you can see them. Yeah. So that's been the standard way of modeling. That's what we're being taught at a university, or at the great courses, and this is what we all start with, and it works actually. It works, but with some warehouses and with some really large-scale projects, or when you need to adapt your schema, you might want something a bit more scalable and flexible. And so what you would do is that you would transform that into the Data Vault 2.0 modeling. So basically, in Data Vault 2.0 modeling, which you can see on the screen, you would no longer have tables with join keys. So this would still sit as physical tables in your warehouse, but instead you would have hubs and satellites and links to basically link them together. So basically the hubs would actually contain your unique business key, which would be the product ID here, to uniquely identify items. Then you would have the satellites, for example, the purchase or the product, which will always contain a lot of kind of descriptive information. And then you would have the link, which would be the link tables between those. And that's Data Vault 2.0 modeling. So you can see that it's actually flexible, because if you want to change your schema or add something, you can just do that in the satellite, or so yeah, it's actually forward and backward compatible, which is great. And yeah, so sorry, that's that's Data Vault modeling. So as you may have seen, there's a version next to the modeling name. So 2.0. So it's because it's an evolution from 1.0, and yeah, basically the improvement of 2.0 is that in 2.0 you have the peak tables, which are point in time, which are made to do a bit of time travel. For example, if you want to if your data is evolving and you want to track different versions of a row, you can do that with the point-in-time tables. Yeah, you have the hash keys, so 2.0 really recommends and relies on having hashing keys functions, which we all have in our data warehouses, but we generally don't use that much. Well, that's what I've seen anyway. Yeah, it really encourages automation, because you really have to automate things, otherwise it's a nightmare to maintain, even more than 1.0. So yeah, yeah, all of that gives a performance boost, because the querying is actually more efficient. You can actually resolve certain views that were very expensive before, things like this. Yeah, and yeah. It's more of a business vault as well, because it can serve more queries efficiently than you could before with the Data Vault 1.0. And yeah, the loading is a bit simpler, as you can just load the versions as is, and then you resolve that as you read the data, as opposed to having to do a complicated kind of resolution at loading time. So it's a bit more optimized for the right time, yeah, which is great. Yeah, so this modeling can be a bit complicated, and especially if you need to create a peak table from your other hubs and satellites. So the amazing DBT community has created 2 packages for that, which are very mature now. So sorry. There are actually more than 2 packages, but these are the 2 main ones which people are actually using. But yeah, there are some out there that may be great, and I don't know about them. My bad. So there's AutomateDB, which is actually created by Data Vault UK, which is very, very popular. And there's a Data Vault for DBT, which I've not used that much, so I will not show you that one today, but it's very good as well. Yeah. So yeah, today we'll see Ultimate DB. So if you, like remember our data modeling, that's what our hub would look like inside of the data vault. So first you can see that you have a dedicated function just for like generating hashes, which is compliant. You also have like an incremental materialization, which is like always useful in DBT to like avoid having your warehouse to like rebuild the entire model. And yeah, you can actually model your relationships. So that would be the example of a hub. That would be a satellite. So same thing. It would be using the hash function and all of the native functions of the Automate DB. Then same for the links. So yeah, it's also supporting incremental. So yeah. And the pointing time table, which are actually easy to generate now. Yeah. So yeah, so just to summarize on the DB 2.0, so it actually scales efficiently with the data growth. It really adapts to data structure changes. It's more future-proof in that aspect. One might say that it simplifies complexity. I know that a lot of people are actually going to fight me on that, especially if you're starting with data vault. It can seem complicated because this is something fairly new. But as you actually as you progress into your data vault journey and become more acquainted with data vault, you realize that the tables have predefined names, which really enable you to see if it's a link or a hub or yeah. You also realize that it's actually easier to query when you need to do your joins and etc. And if you need to do static analysis, you can just query certain tables and actually avoid a join. So that's very powerful. And yeah, and it's also better at data integrity, or actually I would say just as good as third normal form, which is already fairly good. And yeah. So yeah, definitely I would recommend data vault for larger projects, and project with a lot of schema changes, as it's really more flexible than third normal form and star schema, which as you've seen together are kind of very related. Yeah, however, I think that the star schema works well for a simple project, or yeah, this is the default way to start with. Yeah. So yeah. That's that's my talk today. So I think that if there are more if you want to dig a bit more down on the topic, I would love to answer all of your questions or to discuss actually. It's yeah. So, yeah.
Oh my God, there's 3.
Hi, my name is Victor. We are using Databricks currently on the project, and we need some kind of time travel functionality. And we, today, discussed the possibility of using slowly changing dimension, but you mentioned that Data Vault can do it as well. So yeah. Can we consider this as an option?
That's all. Does it work on cloud with AWS, GCP, Azure as well?
Yeah. So yeah, so all of these solutions will also work on the cloud, such as AWS, GCP, and Azure, etc. And then Databricks offers a plethora of options, for time travel. So they have a time travel functionality with their Delta Live table, which is the preferred way of pushing data technology, which actually works well, if you don't mind. Yeah, then yes, you can do the SCB type 2, which would be a way to store all of the versions, and then you can quickly resolve them at query time. Yeah, Data Vault 2.0 offers you the possibility of also having time travel with the point-in-time Pete tables. So you can store every logical version of your row, and then group them by date at query time, or perhaps select the max of the timestamp to get the latest version. And yeah, it's not. I think that both options could work for you. So yeah, both options are compatible. I feel like you need to perhaps think if you want to get into the star schema or if you want to get into the like data vault world, you know. But both options will be compatible for you and would work great on every cloud provider. You have a question?
Yes. So when you're running things in the cloud platform, can DB deploying the environment global parameters or the tags in a cloud system?
In DBT you have a concept of targets, and you can associate these targets with credentials, for example. So if you have multiple environments, let's say like an AWS account, like a GCP project, or etc., you can have DBT pointing to your, to your different database. So I believe that the answer is yes, but I'm not sure if I've actually answered well your question.
So in the back of my head, for example, we already have some workflow built in the cloud that you set up parameters to trigger the wrong weather. Yeah. So sure, if I'm go to DBT solution, can they pull in those set up parameters or particular tags like switch from dev to test? That's in the cloud, not in the DBT.
Yep. Yep. So DBT is an open source software that you either run from a commercial solution or that you install on your own. And basically, you can think of it as this. So first scenario, if you use a open source version, you can actually think of it as a CLI. So then you would use an orchestrator to schedule it on demand, and then to run CLI for you. For example, in ECS Fargate or in Google Cloud GKE or in the Azure Container Service. You could even have your CI/CD pipeline to do that for you. I've seen many projects doing that. I think that is great for development, but then later on in production, you really want it to have automated. Actually, you really want to have it automated past CI/CD pipelines. Mainly because CI/CD pipelines can be a bit limited, even if they offer you an interval scheduler. Right, and that's for open source DBT. Now, if you use the DBT Cloud, which is the commercial offering, then you have a REST API that can actually trigger DBT. So Airflow or Orchestra or whatever great orchestrator you're using, or your CI/CD pipeline can make a REST API call to DBT Cloud to trigger it. Airflow even has a DBT operator which works with it, and then you can trigger the pipeline, and then it runs. And you can track the status as well with the REST API, or the operator will do that for you. So, have I answered my question maybe not? Yes? Cool, yeah. We can talk afterwards, for sure.
Hi, have you ever considered SQL Mesh, which some are touting as the next evolution of DBT? And what do you think are some of the pros and cons of SQL Mesh versus DBT?
Yeah, so...
Someone has an opinion here.
I feel like we love a great community, and a large and well-maintained community. And I feel like DBT has that, and SQL Mesh can be a bit niche. I've actually not looked too much into SQL Mesh because I'm already so satisfied with DBT, though. That's the very one-sided answer here, That's I don't know much actually. There's also the one with Google Cloud that they offer that can just work with BigQuery. I don't remember how it's called. I've actually tried it a little bit. I don't like that it does JavaScript, but it's a great solution overall, and it's directly with your cloud provider, so free, in exchange of you being logged into BigQuery. But yeah, that's a great solution, I think, but has its caveats. Yeah.
Was another.
Hi, I'm Ravi. I had one question for Data Vault and another one for DBT.
Oh, great.
The DBT question is how well does it work with? I know it works with Databricks. What about the performance? How does it work with Databricks in terms of the distributed partitioning and Data Vault, I've heard that Data Vault, a lot of people say it's more suitable for OLTP rather than analytics. Is there a truth in that or not?
These are very, very good questions. So, the good thing with DBT and being asked questions like that is that it's really easy to defend ourselves as we defer all of the problem to the warehouse or the data providers, such as Databricks. Because basically what DBT does is that it actually just schedules query. So what it will do is that it will schedule all of the queries, and then it will monitor Databricks, and then it will ask are you done yet with this one? And then it will just schedule next ones. Let me pull the slides. It's a great but it will just schedule queries in the right order. So in terms of your question about the performance of DBT within Databricks, it will perform just as good as if you just had Databricks that you would trigger yourself or with another orchestrator, because it's just like an orchestrator at the end of the day. But yeah, it can actually handle the Databricks jobs, including serverless. They've really built a partnership that work well with DBT. So if you're automating jobs on Databricks, I would recommend that you give a try to DBT, because they've also got SQL endpoint now, which can work pretty well with SQL. So you could have a simpler data pipeline and a broader audience to help you to contribute. Yeah. Now coming back to your is it cool? Yeah. Then next question is about the Data Vault. So yes, I think it's very suitable for OLTP, but I've actually seen it working very well with OLAP, because I don't see any operation within OLAP that it would prevent, and it's very scalable, which we want in OLAP, and it's not too complicated to understand once you're accustomed to it. Yeah, so I think that it works well. Yeah, for both cases. But most of the time, I've actually seen the Data Vault implemented in the OLAP region, but I've mostly worked in the OLAP region, so I'm a bit biased there. But yeah, it works well with OLAP. Yeah, good question, very good questions. Are there more questions that I can answer? I would love to. No. Oh, there's one here.
So we're already very deep in DBT, so lots of tons of models.
Amen.
Yeah, I know. Preaching to the converted. So we love DBT. It's not necessarily best practice, but we have a very fleshed out lineage, etc. What is is it worth the upheaval of implementing Data Vault type things? If we're pretty happy with how it is now and stuff, what is the real benefit of the the learning curve? I'm used to it, chucking it in.
So that's a lovely question, and this person has actually said that she has a large DBT project, and once you've got to a large DBT project, you realize that you've got to build more tools around it, data lineage, a better orchestration, a way to resolve all of your models, and then perhaps you might be tempted to rethink about your data model. So they have implemented the star schema, or perhaps third normal form, so when it comes to thinking about switching to the Data Vault, I feel if you've actually got maybe some contributors or data analysts, the star schema or the third normal form can be a bit easier to understand for them, because that's most likely what they've seen all of their lives. Plus, I feel if you haven't got any scalability issues, and if we haven't got any kind of schema evolutions issues, then don't get into that niche thing. Yeah, that's what I would recommend.
I think that's a good generally data modeling question. Yeah. I'm quite happy with this. Why should I even bother?
Exactly. I feel for any project, I've really seen this working. You've got to really work with things that are within your scale. Don't try to do it like Apple, Google, and etc. It's really important to stay within your scale. So,
Good advice. over optimize. Yeah, that's all. Any other questions? No, everyone was very keen to get to the pub.